Hello again. This is going to be the last video for section 6, which is on exponent rules and scientific notation. So again, good note taking, list what we're going to be talking about here. So this is section 6, exponent rules and scientific notation. I just wanted to do a few more examples wrapping up exponent rules and also direct you to Blackboard where there is a so let's do just a few more examples. Let's say I have 12x to the 6th divided by 3x to the negative 4th. Okay, I do have like bases here being divided. So what am I allowed to do? I'm allowed to subtract the exponents. I am allowed to view my coefficients and my variables separately. So I can work out 12 divided by 3. I know what 12 divided by 3 is. That's 4. And then here, we're going to take the top, subtract the bottom. So the top exponent minus the bottom exponent. So this is going to be x to the 6 minus negative 4. This is very important because the subtraction is coming from the rule, but the negative 4 is the exponent here. What happens when we have minus minus? Minus minus really becomes plus. And so this is 4x to the 10th. Another way that you could have thought about that is this would be 12x to the 6th over 3x to the negative 4th. We learned in the previous video that x to the negative 4th is really 1 over x to the 4th because it flips into the denominator. This is a very ugly mixed fraction. When I really divide fractions, I keep, change, flip. So this is actually going to flip upward. And this is going to give me 4x to the 6th, x to the 4th, and that is still going to give me 4x to the 10th. So this is two different approaches. I think the first one is easier, okay, because you're just using that one rule. Subtract when you're dividing like bases. Just be careful of the signs. So that's why I wanted to show you that one, all right? Always be careful of the signs. Here's the next one I wanted to make sure that we see. Let's say we had something really ugly. 4 times 3xy to the 6th, all to the 3rd, over 15y to the 9th. But then that whole thing is raised to the 0 power. Look at the big picture. Yes, I could go in and I could try to figure this out, but ultimately this is all being raised to the 0 power. Anything to the 0 power is 1. Okay, we learned in the last video. So don't waste time trying to go through all this. Look at what your exponents are. Okay, and this will boil down and just give you 1. Now, along the same lines of the 0 power rule, if I have negative 7 times x to the 3rd to the 0, this answer is not going to be 1 because the 0 is only affecting this piece. The negative 7 is not being affected by any exponents. So this is going to be negative 7 times 1, which is just negative 7. So this is paying attention to detail. And then the last one I wanted to show you, let's say I had 3 to the 4th divided by 3 to the 6th. Again, this is dividing like bases, so I can subtract these exponents. 3 to the 4 minus 6, which will be 3 to the negative 2. But we don't leave our answers with negative exponents, okay? We want to get into the habit of writing them with positive exponents only. So a negative exponent really tells me that I was dividing. So this is 1 over 3 to the second power, or 1 over 9. Again, there's another way we could have thought about this. I could have expanded this out. There's 4 3's being multiplied on top. There are 6 3's being multiplied on the bottom. These 3's all divide away. They all become 1. And so this is 1 over 3 squared. So I get the same exact answer no matter how I thought about this, okay? But I just wanted to reinforce what these rules actually tell you, okay? So hopefully you are practicing. Like I said, I have, there's extra practice on Blackboard. So now let's move into scientific notation. So now we're going to start the rules for scientific notation. And the reason that scientific notation is important is because if you're doing any kind of science with very, very large or very, very small numbers, you don't want to carry all of those digits along with the number, okay? I'm talking about tiny, tiny numbers like 0.0000592, or really large numbers, billions, trillions, okay? How do we shorten them up? How do we make them easier to work with? The general form of scientific notation is m times 10 to the n. This number is always stuck between 1 and 10. You're trying to make a number that's between 1 and 10, and it's never going to be a 2-digit number. Notice how this is strictly less than. Okay, so it's going to be between 1 and 10, never equaling 10. And the exponent here tells you the number of decimal places that we have moved the decimal point. Okay, so n is the number of decimal places the decimal point is moved. That's really not enough because I don't know if I moved it to the right or if I moved it to the left. Now, I'm not a fan of saying left or right because that will change depending on if you're going to scientific notation or from scientific notation. I would much rather you understand the association here. So n is positive if the original number is large. So if it's a big number, it's going to be a positive exponent. N is negative if the original number is a decimal, is tiny, okay? Now, this should make sense because what did we learn about negative exponents? Negative exponents are division, so they turn things into fractions or decimals. So this should make sense. It all flows from what we learned about exponent rules. This is how we're going to shorten up some numbers. So let's look at a few examples. I want to take 0.000529. And I want to write this in scientific notation. So write in scientific notation. I don't want the decimal point to be here. I want to create a number between 1 and 10. Good news is there's only one place to move the decimal to make that happen. I want the decimal to go between the 5 and the 2. Well, now I have to count. How many places do I have to move it in order to do that? I have to move it 4 places. So the new number that I'm creating is 5.29. That's where I want the decimal point to go, times 10. This has always got to be there, okay? The reason it's times 10 is because every time you move a decimal point, you are moving a place value, which in our place value system is base 10, okay? Tenths, hundredths, thousandths. so we keep moving by a power of 10. We moved it 4 places. However, is it going to be a positive 4 or a negative 4? The original number is tiny, so this should be a negative 4, okay? Let's do a large one to see. I want to take 3,450,000, and I want to write in scientific notation. Right now, the decimal point is here. I want to create a number between 1 and 10, so I would like the decimal point to be here. That's going to give me a new number of 3.45 times 10. How many places did we have to move it? 1, 2, 3, 4, 5, 6. So to the 6th power. And it's going to stay a positive 6 because this is very large. It's a very large number. Okay, now let's practice going from scientific notation. What if you had 4.29 times 10 to the negative 5? We want to write in standard form. Standard form means we want to turn it back into a real number, a decimal or a whole number, okay, whatever it is. What does this tell me? This tells me I'm working with a decimal, okay? Negative 5 is going to be a tiny number. I have to move it back 5 places, the decimal point back 5 places. From here, I have to go 1, 2, 3, 4, 5. What happens to these empty spaces? I fill in zeros. So this would be 0.00000429. If you are unsure, if you have enough zeros, or if you did it right, you can always convert back. So one way is usually easier for people than another. So if you prefer going to scientific notation, then just check this. I would have to move this to this side of the 4, 5 places. And because it's a decimal, it's going to have to be a negative 5. So you can do just a quick check going in the opposite direction. Why is this important? Well, your calculator may not have the capacity to give you an answer as a decimal, okay? For example, look at what I typed in here. I typed in 0.000000529. And when I press enter, the calculator tells me that I typed in 5.29e negative 16. This e is the calculator's way of doing the times 10 to the. So 5.29e negative 16 is just like writing 5.29 times 10 to the negative 16th power. This is important because your calculator might give you these kinds of things as an answer, and you have to know how that translates, okay? So make sure that you're using your calculator wisely, okay? So this was just a quick intro to scientific notation. It helps us out because we don't have to deal with very, very long numbers. All right. So I will see you guys in the next video. Let me know if you have any questions.